Hello friends, welcome to my channel. Let's have a look at a daily challenge problem. Problem 16, 3-sum closest. So this problem is a variant of the classic 3-sum problem. So here we're going to share a solution based on the use of absolute difference or difference. So first I'll read through the statement of the problem to digest the requirements. And then we do a simple analysis, and finally we explain the code line by line. First, the statement. Given an integer array nums of length m and an integer called target, find these three integers in nums such that the sum is closest to target. So we are required to return the sum of the three integers. So here what we are required to return is the sum. So this actually provides us some convenience. So here we may assume that each input would have exactly one solution. So that's not very essential for this problem. So with that said, let's look at example 1. So in example 1, the output is 2. So the three numbers is -1, 1, and 2. So they sum up to 2, and the difference with the target is 1. So in the second example, so this is an extreme case because the length of this array is 3. So we could only choose these three numbers. The sum of these three zeros is for sure 0. So we need to return 0 anyway. So the additional assumptions or constraints for this problem are the following. The first one, the lower bound 3 is an consistency assumption because we need to have at least three numbers. Secondly, the upper bound is 1000. So this is actually not a very large number. The second constraint is on the element range in the nums array. So its lower bound is -1000 and the upper bound is +1000. So the target is in between -10⁴ to +10⁴, both ends inclusive. So with that said, let's look at the single point of to be aware to solve this problem. First, we'll assume that you have some understanding or practiced the 3-sum problem. So if you haven't done that, it's still okay. So we can explain the code line by line. So here, the idea is that we can track the minimal absolute difference of target minus the sum of three elements in the nums array. And the corresponding sign, and also we record the corresponding signed difference. So actually the way we do this is we record the signed difference. So this actually also gives us information about the absolute value, right? So the former, in other words, the absolute difference is used to get closest triplet sum of the three numbers. And the latter is used to recover the sum from target. So here, that's the simple math. Once we find the minimal absolute difference corresponding to the sum of three numbers, then we could use the signed difference to return the 3-sum, right? So the target minus 3-sum, that's the signed difference, right? Then to get the sum, or what we want to return, we just need to use target minus the signed difference. If we record the signed difference by target minus the 3-sum, right? You can use the reverse, but I change a little bit here. So with that said, let's look at the code. So for the code, actually it's rather straightforward in some sense. So first, I'm going to get the length of nums array. So this is just for convenience. So next, we're going to have a data. So I'm going to initialize it to be float +infinity. So this is a signed difference. So this actually we want to use target minus the 3-sum minus s, c. You can actually record s minus target the same, but you need to change the sign here or use and make modifications, so to speak. So next, so in order to carry out a similar program for 3-sums, we need to do a sort. So this sort actually is essential to enable the procedure. So essentially, we are going to do a for loop, and in between, so we have a while loop to do the standard 2-pointer check. So here, let's do this for I in range m. So first we get a fixed element at index I. So let's call this number fixed. And then we are going to use we choose another two elements in the remainder of, or to the right of this index I. So for that, I'm going to initialize high and low to be I plus 1 and m minus 1. Then we're going to do the two pointer. So while low less than high. So what we are going to do is to get a sum first. So it's a fixed plus nums low plus nums high. So this is the sum of three numbers. And let's call it the S3 sum. And then what we want to do is to check if this sum of the three numbers is near, or if it's near to the target, then the three number sums, that is the absolute value of delta. If this is the case, so we're going to update delta to be target minus S. So here I'm storing the signed data, because once we start the signed data, so we can get the absolute value of the delta easily. So this is the update for the delta. So next, let's look at the two pointer logic. So if S is less than target, so we want to make the number larger to in order to be to get near to the target. So we want to increment low by 1. Else, so if S is larger than target, so we're going to decrement high by 1. So there's another case. So if we write code like in this format, so if delta equals 0, so in this case I just need to return target actually. So we can break and then we can use a uniform return. So because we get the smallest delta after this for loop, so in other words, so we get the smallest this number, right? Then we want to get the sum. The sum is nothing but target minus delta, right? So the target minus the smallest data. So that corresponds to the sum. So that's the logic and the if format of solution. So let's first do a special case check. Yeah, it passes a special case. Now let's look at the generic case. Yeah, it passes all the generic cases. I guess for this problem, that's it. And here we presented a solution basically based on the two pointer trick. So actually it's good, might be good to check out the problem for three sums, or in general for n sums. So to practice and make ourselves very familiar with this kind of problems and the corresponding techniques and tricks. With that said, I guess that's it for this video. Thank you.